Dear student, today we will have chapter number 2 about the machine learning, and in this chapter we will discuss very interesting topics which are related to learning. From example, knowledge in learning, that what is knowledge hidden in the data set. So in that one, in knowledge in learning, we will talk about cross validation of our data. We'll talk about confusion matrix, that what is confusion matrix and how it is helpful in finding sensitivity, specificity, and other related metrics. And we will also discuss about bias and variance of the data, ROC and AUC as well, which we call region of convergence. And then entropy, that what is entropy and how it is beneficial for the knowledge in the learning. And then the last thing is the fitting, which model is fitting to avoid underfitting and overfitting. So cross validation. So what is the cross validation? In cross validation, we have some training sets and test sets. So basically, it's a one data set, and we divide into two, like 70% in the training set and 30% into the test set, right? We do first iteration, we make one round, and then we find the error, like what is the error, how many, how many examples were classified correctly and how were not correctly. So we find the error, and then in the second iteration we find another error, in the third and fourth and five, and then we have some collective error by this formula 1 by 5, because there was a 5 iteration. So 1 by 5, and the iteration starts from 1 to 5. So the next thing is knowledge in learning, which one better fits the training data. For example, these 5 points we have it, and we want to see that which line or curve will be fitting it more better. So the goal of machine learning is to make the prediction, right? So we need a way to decide which one is better for making the prediction. So in this one, this line is only touching or approximately touching like 1 point, not many points, but this line is touching all the 5 points, right? Now if there are some more points, so how this will be more fitting into it. And so we can see that the distance is between the line which we have it. So what is the distance between of the new points with the old points? Okay, so here we can see these are so in one model the distance is smaller, and another model distance is lesser, right? So usually the more fitting is the one where the distance is lesser and more closer to it. So the sum of the distances between the real and the prediction, leads to the bias variance trade-off. So we need to make some trade-off between fitting, and we need to look about the biasness as well. So what is the training data? So as I told you that usually for prediction, we divide the data into two parts, for 70% in the training and 30% into the testing. So how predict is a model we learned. So error on the training data is not a good indicator of performance on future data. So if you go for error, that is not a perfect way. So we need some other way. Okay, so yeah, so in this way, because new data will probably not be exactly the same as the training data, right? So overfitting can come, or fitting the training data too precisely, sometime we want to try to cover all the points. So which is overfitting usually leads to poor results in the new data set, right? So that could not be a good model. Yeah. So how to decide which data go into the training set and which data go to the testing set? So we do the cross validation. So for example, this is one example. Like for example, if this person has a chest pain and good blood circulation and block arteries and weight and heart diseases. So heart disease is the classifier. And if there's a new data, like for example, we need to predict for a new patient, if there's a new patient and these have this kind of whether they have a heart disease or not. So we say chest pain, no, good blood circulation, yes, and block arteries, no, weight is 165. So how are we gonna predict for that one? So and which machine learning method will be the best for it, right? So we need to use our experiences, heuristics for that one. How can we decide which one to use? You can see on the left upper corner we have SVM, and then we have decision trees, we have like neural network, we have like regression lines. So which one like we need to choose for that one, or probability based model, naive based model. So cross validation allows us to compare different machine learning methods, and then we need to select which one gives best result or outperforms. So how well these methods will work in a practice? So regression. So regression is mostly like with the quantitative data, but when we say logistic, so it is morely with the like qualitative data, or like the data which is numerical or non-numerical, like yes or no, true or false, high and low, or zero and one. Like so, so usually we translate like yes and no, or true or false, or high low with the with digits like zero and one to make it more easier and flexible. So in the logistic regression, we have two values, like upper value like one and the lower value like zero, right? And there is like threshold value 0.5, which is in the middle, right? So yeah, so here is an example that what are the values which are yes and what are the values which are no. So this is like graphical representation. We need to use all this data to estimate the parameters, like train the model with plenty of data, so that we could have a better like results in the testing and also in the cross validation. So we need to do two things with the data, like estimate the parameters for machine learning methods. In other words, like to use logistic regression, we have to use some other of data to estimate the shapes of the curve. So in machine learning, estimating parameter is called like training the algorithm, right? So whenever we say that we are estimating the parameters, so it means that we are training the algorithm. Or in other words, we can say we need to find out like if the curve will be doing good to categorize the new data or no. We can use 75%, or as I told you in the earlier, it's usually 70 to 75% data for training, and for 30 to 25% for the testing. So what if we use the first block 25% of the data for testing, or what should we, or what about the like third block? Yeah. So here like we see like here we see that we should not worry that too much about which block would be best for testing, like cross validation, use them one at a time, or summarize the result at a time, so we can like shift the block for the testing so that cross validation can be done. Yeah, so this is more examples like you can see over here. Okay, now see here the like first three blocks, like 75% is for training and the 25% is for the testing. So this is not like hard and fast rule. You can like change it. You can make it 80% and 20%, or in practical life sometimes 70%, 30%. So it depends on that one. So in the test, like categorization, five were correct and two were incorrect, right? So you can judge the accuracy, like accuracy is like you can say like five were correct and two were incorrect. So it's more than like 60%. Here you can see like six were correct and one. So here like accuracy is becoming like more better with the third block. So in the end, every block of the data is used for testing, and we can compare methods by seeing how well they usually perform. So like in the logistic regression, like five were correct and two were incorrect categorization. In support vector machine, six were correct and one was incorrect. KNN, four were correct and three were. So there are like different testing cross validation you can do it. So here the best one is like the support vector machine. Yeah. In our example, like we divided the data into four blocks, and this is called four-fold cross, like so here. And when we divide the data in like 10 blocks, this is called 10-fold cross validation. And then we do the parameter tuning as well after that one, like to make it more perfect. What are the evaluation issue? If you want to evaluate our model, so what are the different issues we are facing? So different measure are like classification accuracy, that whether the how much is the accuracy. So we find the accuracy through our confusion matrix. what are like total cost and benefits when different errors involve different costs, like what are the lift and ROC curves, error in the numerical prediction, that what are the different errors, and how reliable are the predicted errors. So these are like different issues we need to like know about that one. Classifier error rates, like natural performance measure for classification problem, like error rate, success instance class is predicted correctly or not correctly. Error are like instances class is predicted incorrectly totally. Error rate, like proportion of the error made over the whole set of the instances. And the training set error rate is very too optimistic, like it's not like realistic, you can say, or you can find pattern even in the random data. So evolution in the like in the large data, like sometimes if many thousands of examples are available, like including several hundred examples from each class, then a simple evolution is sufficient for that one, right? If you randomly split the data into like training and test set, like usually 2 by 3 for the training and 1 by 3 for the test, as we discussed earlier, and then we try to build a classifier like using the train set and evaluate it using the test set. So that is also like possible. So look at this diagram. This diagram will explain it like more perfectly. Like split the data into two sets, as I told you. The first step in classification, like the training set, and then into the testing set. So in the training set, we already know the result, but in the testing, we don't know the results, the classifier. So here we like built a model for that one, and in the model what uh, we see that like that what should be the answer for that one, and we evaluate it based on the prediction. This is the example of confusion matrix, and this is very like fancy kind of example. You can see we have like positive negative on the left hand side and positive negative on the upper side on the column side. So TP means like true positive, FP means like false negative, FP means like false positive, and T means true negative, right? And this is called like confusion matrix. So here this is very interesting one, and it helps you to find accuracy. Like for example, if you accuracy could be like TP plus T and divided by all the parameters like TP plus FN plus FP and TN. So this is like very simple formula accuracy to finding. And then we have FNR, TNR, and then we have like like some formulas for specificity and like error and false positive, and TP are like true positive. So a lot of like formulas you can deduct from this one, and it is very interesting. You will love it if you understand it, right? So just 1 hour, I want to explain to my students. I say that TP, true positive means, for example, like if there is a fire and there is like and there's an alarm, right? So both are like positive and positive, right? And when I say false negative, like means there is no fire, there is no alarm, right? False positive means like for there is a fire and there is no alarm, right? And true negative means like there is no alarm, there is like there is alarm but there is no fire, right? So this is just like to make it remember, but like you can have some more like simile on that one to remember all these things. So this is like real confusion matrix, and here you can see that what is like what is the output for that one, and this is based on the very popular iris data set, which is called iris data set. And this iris data set has like sepal width and length, and petal width and length, and like for the different flowers, and the flowers are like Setosa, versicolor, and virginica. So these are the different labels over there, and from this one you can find it the different like accuracy and all this. Yeah, so confusion matrix, if you want to apply a machine learning method to predict customer churn of a telecom enterprise, like house, we have it. Yes, so this is one of another example, like house income of your data. You have internet service and monthly charges and tech support, and the classifier is churn. So churn means like here yes or no. So we have two like available. So let's see how we can classify it by the confusion matrix. So we can use different methods. Yeah. So by logistic method, this would be the results. Support vector will like differentiate between yes and no, and KNN will have different clusters. So this is like three different things. So which one is the best? So you have to decide about that one. So we start by dividing the